Hey, hi guys. It's actually quite late, but I still thought I should make a small video for you guys today. So you see something new behind me. That's the Code Wizards logo. I'll just show it to you before we go ahead. Oh, sorry. Yeah. So this is the Code Wizards logo. And if you're wondering why we chose the name Code Wizards, there was actually a lot of brainstorming when we made the name of the academy and came up with the logo. So you can see a little wizard hat and a little bit of a Halloween theme there. So like it looks like a little bit of a pumpkin. So try to give it a magical theme to the logo. And but why do we call it Code Wizards? This is actually inspired by a quote from the this founder of the company, founder and maker of the company Valve, which is responsible for creating games like Half-Life and the platform Steam, from which so many of you download interesting games all the time. So he had a quote and he said, "The programmers of today are the wizards of tomorrow." That's actually true because programming gives you a magical skill which lets you create so many different things. Actually, half the world is right now running on programming, whether it's ordering your grocery, whether it's booking a cab, whether it's booking a train ticket, flight ticket, or even a restaurant table, or whether it is your what else? I mean, I actually can't imagine things that don't run on software, including the Zoom recording that I'm doing right now. So from anything to everything, even your car has a chip which has some programming, which is actually running some programs. It is called the engine control unit, the ECU, which is like a little bit like the Intel or AMD processors in your laptop. So programming is a magical skill, not only because it runs the world right now, half of the world runs on programming, something or the other related to programming, but it gives you a magical mindset. It lets you break down bigger problems into smaller bits, focus on one at a time. And I will just take a small while to recite a poem that I had written myself when I became a programmer for the first time. Not exactly at that time, but 2 3 years down the line, I realized that this making games is giving me a power to think and solve really difficult problems. But how do you solve those problems? What you do is you take a big problem, whatever problem you have, and you decide some kind of a vague sequence of how this problem can be broken down into smaller parts. And then at each instance, you focus on one small part because your brain can only process that much. Now, things, the order and stuff might change, but the whole process then starts moving along. If that chunk is too big, then even break it down further and further and further until you get a problem statement that you can handle easily. If not easily, at least it is something that you can work on and you can visualize the solution. So here goes the poem. It is based on the jack, which is the tool used to lift vehicles when they are punctured or they've developed some faults in the bottom, which somebody has to go into, or they need to lift the car. So typical example is a puncture tire. So imagine a truck. Let's not take a small example. Imagine a truck which has got a flat tire. Now, do you think even the greatest less wrestler of the world can lift that, how many tons, 2 or 3 tons, or maybe even more heavy truck? Cannot, right? How do they fix the tires of a truck? So they use the tool jack. So what the jack does is it just moves very little at a time, but with a lever which is so big that you can put all the effort into lifting just this much. Then you do again, you put all the effort into lifting and you keep doing this again and again. And in a very short time, you'll see that the truck, the massive truck, which even heavy lifters from WWE like Great Mahan, Undertaker, this, that, they cannot lift up, has got lifted with an average mechanic strength who's not even a bodybuilder. So here goes the poem. Remember the jack and forget what you lack. Put all your effort into lifting a bit and do it so that it will stick. In a very short time, you will have seen what has got done could never have been. That's the way to defeat the impossible and say to yourself, bring it on. I am possible. Okay, so that's the philosophy of programming also. That's the kind of spirit of programming in which you take a big problem, put all your effort, all your thinking abilities into an analytical abilities into solving that part. Then you keep doing that again and again and again and again, and ultimately the problem becomes the big problem that you could not think of in the to how to solve actually becomes broken down into smaller parts, and then you tackle the smaller parts and your problem gets solved. Today we are going to do something exactly similar on those lines. We are going to make a bouncy ball. Now, let me now start sharing my screen. Yeah, so this is my screen, which is showing you the Scratch interface. Now, first, let me take a ball sprite to start with. I think there are tons of ball sprites available here. People, music, dance. So this will come under the sports category. And which ball should we take? You tell me. So I think basketball works fine for us. Now, problem. How do you make a bouncy ball? One simple way is just say move 10 steps, give a random angle, and say if on edge bounce. But that would be too simple. That is, first of all, the first thing is that it is too simple. The second problem is I feel that it gives you very little control. If you're trying to make something bigger than a simple bouncy ball, then it will start giving you problems because you will not know uh, what to do when something happens. When the ball reaches the edge, you don't really know exactly at that point what to do. I mean, it will just bounce and it will not really tell you that the ball has reached the edge and stuff like that. You try to make a bouncy ball related game and you'll realize that. Anyway, you don't want to do it the easy way, not because we don't like to do it the easy way, because it will not help us learn anything new. So one misconception that I want to tell everyone, or I mean primarily my students here, is that some people say there's a joke that if there's any difficult task, you should give it to the engineers because engineers are lazy and they will find the easiest way to do something. That's not really true. Engineers are not lazy; they are efficient. There's a big difference between efficiency and laziness. Efficiency is not about wasting energy. Actually, engineers are probably one of the most hardworking people out there. They solve problems. They try to make their efforts efficient so that they can be used for better purposes. Probably they'll make a robot that will put a glass to their lip, but that is not because they want to sleep all day. That is because they can focus their efforts on something else. Okay, so laziness and efficiency are two different things. Being efficient does not mean you're lazy, and actually there's no problem if you have done something really interesting that saves you effort, then you have earned your laziness. I think that laziness is not really bad, but the effort that needs to go into solving a big problem so that you can save your own human effort, that's actually a very very hard work. So we'll see how that is a lot of hard work. So coming back to the point, now your ball, how do you even start making a bouncing ball which is bouncing all around? What kind of, so one simple easy explanation would be, you will say just glide to random position. Is that the right way? Just let's test it out. Again, coming back to my previous comment about iterative development, try, make mistakes, fail, then again learn, and then do the loop again. Do you think this looks like a bouncy ball? It's just going randomly somewhere. It does not nearly look like a bouncy ball. It looks like a mad ball actually, which has a mind of its own and it's just going crazy. That's not what we want to make. We want to make a proper physical looking bouncing ball which is bouncing on the screen all the time. How do we do that? Coming back to the jack. First, break down the problem. How can we even break down the problem? What does a bouncing ball do? It is bouncing, bouncing, bouncing. But before it is bouncing, can we try to make a more simpler, dumbed down version of the same problem? Again, breaking it down. So can we say, shall we make a bouncing ball which is just going left and right? That's one part. That's possibly one part. Then we'll see how to add the vertical movement. What if we make a ball change x and change y? It's actually going to slant. If it is going to slant, then how will it bounce? What will happen when it bounces down? So if you notice, so okay, so first part is let's just focus on how to make a ball go left and right. Okay, that's our focus. Our Jack has given us this. Jack philosophy has given us the answer that don't think of the entire problem right now. First, break it down into the smaller part. The second step is make the bouncing ball go in a slanting way. And then the last part is when it is going slanting, when it reaches the vertical or the bottom walls or the edges, make it again bounce up. Now, if the ball, probably this is what I'm thinking. Probably if this we get this right, if we are able to make it bounce on the top wall and also make it come down, and then the same thing happens on the bottom and the right and the left walls, then probably our bouncing ball is done. Okay, so let's first do a dumb version of it. Okay, again, how can you make a ball go right and left? Again, break it down. Even so that the thought is not getting, um, you know, um, fit into your mind, right? Or my mind initially when I was doing it. So if you don't know how to make it go right, left, horizontally, shall we break it down even further? Shall we say, let's just make it go right? That's very simple. I think all of you know how to make a ball or any sprite go right. That is simply change x by 10. So once a thought comes in your mind, you test it out instead of doing a speculation. So this is the difference between Greek philosophy and the Roman philosophy that came up later. The Greeks were very speculative. The later Romans who came up, Romans and the Europeans, Copernicus, Galileo, etc., They were very experimental. So Galileo came up with the idea of experimenting, verifying your facts and thoughts before going further into theory. That's the basic difference. So you have to be a Galileo. You don't have to be a Socrates or a Plato, or who the Greek thinkers who made massive amounts of thought in their brain, but never really had the good thought that we should actually test little bits of our theory out in the real world. Galileo did that. Galileo said, without experiment, you don't have science, and that's why we are where we are, because that spark of experimentation and verifying the facts, that's where things started moving in the whole world of science, and then Newton came along and all that. So let's just first do this small little thing of change experiment. Okay, so at least half of it is done. Congratulations. You may be thinking this guy is encouraging us too much, or just crying a lot and saying a lot of big things just to make change experiment, just by doing change experiment. What is a big deal? Now the second problem is, now when it reaches here, it should bounce back. What does it mean? So first, again, now break it down. What does it mean when I say in English, think in English, write in code? Think in English, think in Hindi, think in Telugu, think in Malayalam, write in code. I always keep saying, what does it mean that the ball has reached the right edge? What is changing? Look down. Look down in the data here, somewhere here. What is changing most about the ball? Can you notice that the X is what is changing? Of course, X is changing. But what is special about the X on the right side? It is 236, which is actually the right limit. 236 or 250 is the right limit. But the moment it reaches here, we want to bring it back. So 217. So how do you say if the ball reaches 216? That means if it is little bit greater than 216, it will never be equal. So how do you say that if the ball is greater, X is greater than 260, so you take the greater than sign. If condition, if the ball's X position is greater than 260. So X position is greater than 260. What do you do? Now you wanted to go back. So the simple answer would be change X by -10. Let's see. Instead of saying anything about it, I want you to see what happens. Let's put it here again. It got stuck. Why? Why? Because the moment it got more than 260, it came back. Then what happened? It again went 260. So it's actually stuck. It's actually vibrating so small that you can't really see it. If the exposition goes greater than 60, it's coming back -10. In the very next loop, this is getting executed. So we don't want these two blocks to be executed at the same time. What we want is this only one change X. Either it goes right or it goes left. So how do you do that? Variables. So we want this whole thing only to do one thing. Either change X by only one value. Either it's 10 or -10. When will it be 10? When it is going towards the right. When will it be -10? When it reaches the right edge. So what we'll do is we'll create a variable called X speed. This variable will keep flipping from 10 and -10. So when it reaches the right edge, make it -10. When it reaches the left edge, make it 10. So how do you make it? If it is greater than 260, let's make it what variable? X speed. Let's make it -10. And let's try. Okay. Okay, let me start from here. First, let me make my speed as X speed is 0. And oh, you know what? I never really used my variable. I'm always changing my X. I made a mistake. Mistakes are normal. Now let me try. The ball is not moving. What mistake did I do now? I always keep making mistakes. It makes me frustrated. But you should not be frustrated because it's a very small mistake. A small mistake is we never set the speed to anything at all. So it's right now at 0. Let's make it to 10, which was our original speed. So it's moving to 10. And then when the moment it goes greater than 260, actually it's not 260, it should be 230. Now let's see. Now if our code is correct, the ball should bounce back. It's not 230, 225, right? Not 2250. You have to be very careful about each and every number. Yippee, it came back, but it's stuck on the left. Why? Pretty obvious, because we never wrote the code for the left side. So now we will duplicate it and we will just change what? Detect the left side. How do you say detect left side? If it is less than a negative number. So X position less than. So we'll change the operator to less than. Now you should be very well aware that this is the less than sign. and exact symmetrical. So it's 225 on the right, so it's minus 225 on the left side, right? Nothing much to think about. And what do? We change the speed to the same speed, which makes it go right. What is that speed? It is 10. Got it. I got it. I got it. Got it. Got it. Okay. So good. I got it. Now comes the big problem. Now this is not a bouncing ball because it's just going left, right. But that's not a bouncing ball. That's just a simple ball. What can you call it? It's not bouncing. It's just ping ponging. How do you make it bounce all over the place? Maybe change the direction. Let's try that. Let me try. So keep trying. The idea is not to try to be perfect in the first go. Keep trying. Trial will give you an insight. Whether if you're right, you get it. You get move ahead. If you're wrong, you learn something. So either you get it right or you learn something. It's not a loss either. Shall I make my video on this side of the screen so that I can appear a little bigger? I want you to see me while I'm talking instead of being a small little tiny little blob. That reminds me of a joke. So there was an event happening where I stayed. I used to live in an academic campus where there used to be a lot of student events happening and all. So for the first time in my life, I saw a news shoot. I mean, a camera uh, crew come and shoot that event, and they came and shot the event. And I was so desperate to get on TV, and we knew that this was going to be coming on the news channel or whatever the in the some kind of a TV channel. It was some TV program. It was going to come. So me and my friend were very excited. We were shouting, "Yay, yay, yay, yay!" And we got covered by the camera screen. And finally, when it came in the TV, so we could hardly see ourselves. But then when people asked us, we had to say, we had told everybody we are going to be on TV. So people asked us, where are you? Where are you? Where are you? Said, we are there, right there. You can see us. Where you can see us. We are there on the camera. But where are you? Where are you? And we have to say, that small little dot that you see 3 rows behind, that's us. So I don't want to be that small little dot in the screen. So let me be slightly bigger, and let me come on Zoom. Give me a break. Yeah. So I wanted to make this a little smaller. So now what are we doing? Now we cracked one part of the problem. The second is we want to turn it a little or see. Let's see what happens. So the ball is now rolling. It appears to be rolling. That is interesting. We got a new effect, but it is still not going to go left and right. Why? Because it's only moving by this block, change X. But change X is always going to move it left and right. There's no vertical movement. So change X will do horizontal, vertical, horizontal. Is there a connection? If X does the horizontal, what is the vertical? Come on, guys, you can do this. Guess. Change. Again, change, but this time it's going to be change of Y. So let's do change Y by 10 and see. Just randomly put it. You make a mistake, make a mistake. At least, but yeah, whatever mistakes you do, if they don't work, if you realize that it's a mistake, then, and if it's causing some harm, then better you remove it. Okay. Even though it's kind of harmless in this case, but reverse that. It's okay. I mean, better to have it simple. Keep your code simple and stupid. That's called the KISS principle. It's funny, right? KISS principle. Keep it simple and stupid. Something happened, something happened. It looked as if, oh, but it went in a slant. It's going in a slant, but it bounced also. See? Okay, let me check. What happened? What do you think, guys? So it is when it's going up, it is not coming down. Why? When it went right, it came back. When it went left, it came back. Do you think we have ever written a condition by which it will come back for the Y? So first of all, let's write a condition. Again, breakdown. Again, we don't know what to do yet when it reaches the top. But we know that we have to do something when it reaches the top. So first, at least let's write a condition by which we come to know that the ball has reached the vertical top edge of the screen. So what is the condition? Now you guys will tell me. Think about it for a second. Take a pause. And based on this code that you have seen, tell me the condition, or think in your mind. Close your eyes and think in your mind. What will be the condition that is needed to detect that the ball has touched the top and or the bottom edge of the screen? Any guesses? Any guesses? Think. Nothing? So I'll tell you. I think you've thought about it, but so we'll have to move ahead. So it is if the Y is greater than this value. What is this value at the Y? It's 156. So if the y becomes even a little bit bigger than 156, that means it has reached the top. Equality condition we cannot test because exactly equal, it may skip because we are increasing by 10. What if it is 150 at one point and then it becomes 160? So it is exactly never going to be equal to, what is the y? 152. So we are just exactly going to take the 152 and let's do one thing. Instead of going too far, let's just test a condition. So again, Galileo tells us that even if you think small, test your thought. Test your thought before you even take a step back. So how will you even test this? Isn't it very simple? If it goes up, just change the color effect to something. That means we'll know that if we are detecting that the ball is touching the top. Yeah, see. So we detected our condition is good. Now, similarly, you will realize that the condition for the bottom will be exactly symmetrical. The screen is exactly symmetrical. So it will be minus 152. So now our condition is tested. We'll take this block out. Now we have to decide what to do with the y movement. Now we are clear that the y movement is happening because of the change y by 10. Is there a doubt about it? There's no doubt about it. Try to see similarities now between the x and the y. If the x is, the code is like this, probably the y code would be similar, right? Because we want the y, once it goes up means it's not going straight. But if you think a slanting movement, actually again think of a breakdown. A slanting movement, if you see, is horizontal movement is like this, vertical movement is like this. But what if both are happening at the same time? It's actually a slanting movement, right? So slanting is no magic. There is no magical about it. It's just that both the movements are happening at exactly the same time. And actually, this was also one of the brilliant insights given by Galileo, that these two motions can be separated out completely, the vertical movement and the horizontal movement. So based on that, he could come up with a lot of equations that could predict projectile motion. When you throw something, how will that projectile behave? Like your Angry Birds, you throw something, it's actually calculating a projectile motion. So the simple answer is we'll again create a variable called y speed, and then this y speed will go here. Now I think by now it's clear that when it reaches the top, the y speed should go down, which is it should change by negative. So it should become minus 10, and then when it goes up, when it reaches the bottoms of the screen, or bottom of the screen, I made a mistake here again. It is, instead of minus 152, I use minus 252 because the screen is not kind of symmetrical. It's not a square, it's a rectangle. It's smaller in the vertical and bigger in the horizontal. So I'll say now my y speed is going to be, when it goes up, it's positive, right? It's positive 10. So let's see. But not moving. What is happening? Change y by what is happening? So let's think. So creating solutions is probably as important, or fixing problems in your solution is probably as important as coming up with the core idea itself. So I think the core idea seems to be okay, but there's something that has gone wrong. What is it? Now, why is it not even moving up and down? We have done change y by y speed. What is y speed? Ayo, y speed is zero. That is like giving you zero money every day. I'll say I'm a very generous guy. I'll give you some money every day and everybody will be rich and I'll be a great man. But what is that money? Anda. That means I'm not giving you anything, right? You'll not get richer if you get anda. So the y will not change if it does not move by anything at all. We'll change again this y speed by, come on, help me here. Scratch 10. Now let's see. Something happened. But it's not getting, it's getting stuck. But we have written that condition, when it reaches up, you become negative. So shall we check that condition? This is the condition. If y position, let's read it carefully. That's how you debug. If y position is greater than 152, set my, put it as my variable. I said, but I didn't do. Kada. We didn't do. So we never chose the y speed. That's the problem. Instead of setting a y speed, we were changing the variable. This always happens. It's human error. It's natural. It happens to the best of us. Whether it's a big programmer, whether it's a small programmer, the only difference is the experienced programmer make less of these mistakes and they make bigger mistakes. They make you the smaller programmers, the kids make mistakes which will probably make the ball go haywire or wrongly in Scratch. The junior programmers, the big programmers make mistakes which make rockets crash into the ocean instead of go to Mars. Okay, that is the only difference. Everybody makes mistakes, make mistakes and learn. That is the only way to genuinely learn. Sometimes you have to learn from mistakes of other people like me. Not always you have to make all the mistakes yourself, otherwise it will be a very costly affair. Costly as in it will cost you your time, it will cost you your energy, it will cost you your mental peace. So sometimes you have to learn from the mistakes of others, that some common mistakes you will probably understand. So wait. I just want Zoom, you need to help me here. I'm not able to zoom down. Let me reduce my video here, and so the zoom screen is coming up where I have to zoom out. Is there another way to zoom out? Edit, turn on turbo mode. There is no way to zoom out, and the scratch screen is somehow getting overlapped with the. Oh yeah, I can do this. Yes. So I'll zoom out and bring my talkie face out here, which is overlapping the code wizard's logo. In he logo ne. You heard that song? It's a very old song. Sorry, bad joke. Okay, now let's see. It is still getting stuck. Why? Why is the Y going up? So if the position is greater than 152, is this correct? 152, then set Y speed to -10. I think that's a reasonable code, and change Y by Y speed. And if the Y position is another mistake, buddy, my Y speed is going to become 10 again. Why? Because instead of saying if it is less than -152, if it goes down, it should be less than -52. No, greater than -152, it will be here also. So I have to use a, see, I'm making so many mistakes, and that's completely normal and completely natural. Only thing is, the better you are, you'll make faster mistakes, and probably you'll avoid some common mistakes altogether. The more you practice Scratch or programming or thinking, the lesser is the number of mistakes you make. So if it goes down, means it goes below 152, only then make it go up by changing the Y speed to 10. I hope all this is making sense. And high five on that. We got a bouncy ball going. And what? And what? So I'll leave the challenge to you to take this. Okay, first of all, none of the videos should be copied as is. Anybody, you can make an entire platform a game by just copying the code. This video was made so that you learn how to think. Programming is not something that you're doing to become software engineers, but it is something that you're doing to have fun, to make bouncy balls, but at the same time, learn the art of patience, learn the art of problem solving, learn that mistakes are normal, learn that mistakes are common. It happens to the best of us. That is why you have, and learn, probably the most important learning from this video was that you are whenever given a big problem that is beyond your mental capacity, which is very normal because everybody has a limited mental capacity. Maybe Einstein had a very massive mental capacity because he probably was very interested in practice those kind of thought patterns all the time. Don't think Einstein was not working hard because he didn't go to college. He was thinking. Thinking is the hardest work that is possible. You know, according to some research, thinking consumes more glucose than probably weightlifting. So brain power is actually more powerful than brawn power, even in terms of the amount of energy you consume. I mean, even if you look at it from the energy perspective. Energy perspective. Why am I using these big words? From the angle or from the view of the energy. So when a problem is too big, which is very normal when you think of these this is actually a very mathematical code. You're thinking of coordinate systems, you greater than, less than, and a very logical sequence of steps. So that's very mathematical in nature. When you're thinking of a mathematical problem or an engineering problem, a problem is most often not going to fit in your head in one go. Even for us, very experienced software engineers, I am an experienced software engineer, game developer. When you give me a problem statement, or this is the problem that you need to solve, most likely I'll not be able to come up with the entire scheme because God or nature has given us a very limited brain capacity, right? There's only so much that we can fit into our brain at a single given point of time. According to one research, Even about the amount of choices, you can choose only among 7 choices at a time. So that's why I get totally confused when I see 100 movies on Netflix, 100 options on Amazon. It's actually scientifically impossible, and it makes you very uncomfortable to choose so many things. So our brain has a lot of limitations, although it is very good in some respects, like remembering very very old things, but it is actually also very limited in a lot of aspects. And one of the aspects is that you cannot think of a lot of things at the same time. That's why this engineering attitude of breaking problems down into smaller bits. Focus all your attention on one bit, solve it, go to the next, do the exact same thing with that one. If it is too big, break it down further into smaller ones. Then focus your attention on one at a time. Keep chomping. How do you eat food? When I give you a plate, when your mom gives you a plate of food, or when you order McDonald's burger, fries, and Coke, do you take the whole tray and like an ogre? Do you do that? No. You take one French fries or two French fries at a time. Then you eat, and then you eat, and you eat, and you eat, and then after some time, the plate is clean, and then you're licking your fingers. So that's exactly the kind of attitude you have to bring to problem solving. And Scratch, you can actually do that. So we also, Code Wizards Academy has live classes, and we actually take live classes for kids, and we our lovely instructors help you have a lot of fun while having while developing your problem solving and analytical thinking skills and having a lot of fun. We don't use these boring ready-made sprites. We use a lot of variety of sprites that we download. We have kept ready for you from the internet. We do a lot of interesting games like the platformer, like shooting, like jumping, like the Flappy Bird. So we do a lot of interesting projects and problems, and you guys will just have a lot of fun just learning all these projects, as at the same time struggling, learning to struggle and solve big problems. If you're interested, you can just put in the comments that you want a free demo. We'll be happy to arrange a free demo for you. And our classes are reasonable. They happen twice a week, 2 hours, for a batch of 3-4 kids together, so that you can together come and solve problems and have share some jokes and have some fun. That's how our classes work. For a free demo, please message us that you're interested in a free demo. We'll probably send you a message and schedule a free demo for you. Also, if you like this video, please press the like button. Also, do subscribe to our channel and press the bell icon for more updates. Thank you for watching, and have a good Ganesha holiday tomorrow. Happy Ganesh Chaturthi. Thank you very much, guys. Good night and bye bye.